Hey guys, this is a quick review of the topics from Chapter 6, which is all about exponential functions, exponential growth and decay, and sequences. If you haven't tried all of these problems yet, go ahead and do that first, and then come back and watch the video and make sure that you got them right, or if you needed more explanation, we can do that with the video. So the first question says to use the function f of x equal to 12 times 1/2 raised to the x power to answer the following questions. Now this is an exponential function because the x is an exponent, so we know that this is the type of function we're going to use. Just to remind ourselves, an exponential function basic form is a times b raised to the x power. That's the pattern we use for these types of functions. This is not on your formula chart, so it is something you're going to have to memorize. First question asks, what is the initial amount? Well, the initial amount is always your a value in this function. It's also called the y-intercept, and for this function, there's a 12 in the spot of the a. So our initial amount is 12. Letter B asks, what is the constant ratio? Constant ratio, okay, or factor might be another word you heard here. The constant ratio or factor is the b value. It's telling you how this graph is changing each time, what I'm multiplying by each time to get new numbers. Our b value, which is the number in the parentheses or the number with the floaty boy next to it, with the exponent, is 1/2. Since that constant ratio is a fraction, or like a division problem, this is going to be a decreasing function, which means it should be going down or getting smaller. The domain of any exponential function that doesn't have context, so just regular math problem, if we're thinking about the x values, is going to be all real numbers. Or you can make the fun and funky R that stands for all real numbers. Now we know this because the graph doesn't have any stopping points. For just a regular mathematical function with no context, we would answer all real numbers for the domain. For the range, we have to know what our a value is because we're talking about the y's. But we know that my range includes the number 12. That's a positive number, and that's a number bigger than 0. So what we would answer this question is we would say all of the graph, y represents the graph, all of the graph is above 0. Because the entire thing is going to show up in the top 2 quadrants, since my initial amount is also positive. Letter F asks, what is the equation of the asymptote? Now the asymptote, if you remember, is a vocabulary word that's like the I'm not touching you line, like when you annoy your siblings and you say, I'm not touching you, I'm not touching you. Well, this is going to be the same for the majority of all of the mathematical questions we talk about. The asymptote is the line y equals 0. Okay, the line y equals 0 is a flat line because hoi, and at 0, which means it's really just my x-axis. Your exponential functions should never cross that dashed line. That's the asymptote. Letter G, graph the function using the coordinate grid on the right. Well, for graphing the function, we know the initial amount is 12, so I come up here on the y-axis to 12, and I plot my first point. And then I move by 1/2. But that doesn't mean I just go down 1/2. That was for linear. What it means is that I take 1/2 of 12. Well, 1/2 of 12 is 6, so the next coordinate should be at 6. And 1/2 of 6 is 3. And 1/2 of, oh, I plotted that on the wrong one. Haha, ignore that. 1/2 of 3 is 1.5. So as I'm graphing this, I see that my graph is going down or decreasing, like I said it should, and it should get closer and closer to the x-axis without ever touching it, because that asymptote tells me I cannot touch that line. Letter H says to evaluate f of 3. Well, this is function notation, so it's asking me to evaluate what 12 times 1/2 raised to the 3rd power is. Because a second ago there was an x as my exponent, and an x in this parentheses. Well, now there's a 3 in the parentheses, so I make a 3 my exponent. All we do is we throw that in a calculator, unless you want to try it in your brain. I recommend the calculator. We would do 12 times the fraction 1/2 raised to the third power. Oh, you can't see it because of the glare. Now, if you want to know how to put the exponent in, it's this button right here called the up caret. The up caret gets you into exponent world, and we would get 3/2 or 1.5 when we evaluate this function. Which makes sense because if we keep going down and down, we're going to get to 1.5 for number 3. 1.5. That's what we got. Number 2 is a growth and decay question. It says a certain stock was worth $108 at the beginning of the month. Every day the stock goes down by 36%. From that information, there's 3 things that are important. The first thing is the beginning amount of the stock. The next word is goes down. You may also see the word decreasing. Then we have a percentage. Okay, your percentages always give you a rate. Interest rates and other type of rates are always given as percentages. But to use percentages, we know we need to change this to a decimal. So we would move the decimal place twice, and we'd get 0.36 is the same as 36%. All of that information I know just from reading the beginning part. So let's start with the questions. What is the initial amount? Well, they already told us that the stock started at $108. Letter B, does this model growth or decay? Well, we see the word goes down. Goes down is the same as the word decreases, which indicates that we are decaying or getting smaller or going down. Letter C, what is the growth or decay rate? Well, we know this is a decay rate. But rate is your R value. We already said that the R is 36%. But we would use 0.36 in my formula. Letter D, what is the growth or decay factor? But again, we're doing a decay factor. If you guys remember, the factor is your B value. So I have to actually solve for my B value here. For decay functions, we know that this should be the same as 1 minus R. Because we're decaying, so this has to be a subtraction problem. Well, I know what R is. R is 0.36. And what is 1 minus 0.36? 0.64. 0.64 would be my decay factor, my B value. E asks me to write the equation. I'm going to write it in 2 forms, the simplified and the expanded version. If we remember, decay follows this pattern. Initial value, 1 minus rate raised to the time. Okay, so let's fill that in. We would have y equals, we started with $108 and we decreased by 36% each month. Or we can simplify this down to 108 times 0.64 raised to the t power. This is called the expanded form. It contains the initial value and the rate. The simplified form contains the initial value and the factor. Now, since this is a contextual question, we know that time is being represented here. When we're asked about the domain, we no longer answer all real numbers because you can't go back in time. We can't have negative time. So we would say that the graph only shows up in the positive numbers, where x is bigger than or equal to 0, because time always goes forward or towards the positive numbers. For the range, okay, we know that this graph, or this stock, starts at $108 and it goes down. But since this is an exponential, it can never touch 0. It's going to look something like this. Okay, here's 108 and it'll go down. But it will never touch 0 because they're not allowed to. So when we're talking about the range, we would say it's bigger than 0, but it has to be less than that initial value of 108. Because the graph can only show up between the first value and things that are smaller since the stock is decreasing. What is the equation of the asymptote? The asymptote equation is the same for every single one. It's always y equals 0. Letter I. What is the stock worth after a work week? Now, a work week is not like a calendar week. A work week is 5 days, like you go to school 5 days a week and then you have 2 weekend days. So we want to know what the stock would be worth at the end of 5 days. That's asking you to do like number H up here, to evaluate our function. We want to know what our $108 stock would be worth after decreasing at 36% each day for 5 days. Okay, when we plug that in our calculator, we would say 108 times 1 minus 0.36 raised to the, remember, raised to the 5th power. Rounding to the nearest hundredth, because we're using money, this would be $11.60. That's how much the stock is worth at the end of the week if it continues to decay at 36%. Sequences on the back. If we consider this sequence, we have 972, 324, 108, 36, and on and on and on. We got to answer some questions. First, we need to know, is this sequence arithmetic or geometric? Remember that arithmetic sequences go up by addition or subtraction, and geometric sequences change with multiplication or division. So is this going up by a consistent number with adding or subtracting, or multiplying and dividing? Considering the numbers are getting small very quickly, we know that this is going down by dividing. This is a geometric sequence. Since it's a geometric sequence, we know that it cannot have a common difference, because that has to do with arithmetic, but it will have a common ratio. We find the common ratio by taking the second number in our sequence and dividing it by the first number in our sequence. So second number, first number. All right, so we would do 324 divided by 972. Calculator tells me 1/3, so my common ratio is 1/3, meaning we're dividing by 3 each step in our sequence. Write the next 3 terms in the sequence. Well, since we know we're dividing by 3 each time, when we're writing the sequence, 972, 324, 108, 36, what do I have to do to get the next number in this sequence? I have to divide by 3, or multiply by 1/3. So 36 divided by 3, that's 12. 12 divided by 3, that's 4. And 4 divided by 3, that's 1.33, or the fraction, 4/3. And there we have the next 3 terms in our sequence. 12, 4, and 4/3. Follow the same pattern as the other numbers, we just continued it. Number 4 says consider the sequence a sub n equal to a sub n minus 1 plus 5, where a sub 1 is equal to negative 20. Whoa. Really, this is not any harder than number 3. We just have to figure out what type of sequence we have and what we're doing each time. Okay, don't worry about all the notation. Just worry about a couple things. What does this tell me we're doing each time? Does it tell me we're multiplying by a number or adding or subtracting by a number? Literally, you see the plus sign, so you know this has to be arithmetic, because that's the one that goes up or down by addition or subtraction. That means we don't have a common ratio, but our common difference is just this number right here. So my common difference is 5. That means each time I move in my sequence, I'm going up by 5. Easy peasy. Well, number C says, what are the first 4 terms in the sequence? How do you know where to start? Well, it's literally given to you. Remember, sequences are told to you in a specific order. This notation right here says the first term is negative 20. The first term, 1, is negative 20. So, okay, first term, negative 20. Cool. If there are answer choices that didn't start with negative 20, I'd get rid of them. And then the sequence itself tells me that I'm going up by 5 each time. So, in my brain or my calculator, negative 20, I'm going to go up 5. I'd get negative 15. 1, 2. We need 2 more sequences. So we go up 5 again. We'd get negative 10. We need 1 more. We'd go up 5 again. We'd get negative 5. There's our first 4 terms in this sequence. We started at negative 20. Start at negative 20. And we're going up by 5 each time. Plus 5, plus 5, plus 5. In the space below, please write down any other notes, ideas, comments, or concepts you may need to study and or review for this test. That means going back through your notes, going back through this review for things that you learned or clarified for yourself, and rewriting them. We ask you to rewrite them because rewriting things actually helps you remember them more. The more you write it down, the more you'll naturally know about it. If you need to go through your notes, if you need to Google some more videos to figure out more concepts, go ahead and do that. This is your time to study.